we keep both adding. All right.
Okay, hello. Hi, everyone. Welcome to the very special Blazor community stand-up for January 22. Today, we have a very special guest with us, Steve Sanderson, who's the creator of the Blazor framework. Steve, do you want to introduce yourself a bit?
Sure. Okay. So yeah, I'm Steve. I work for Microsoft. I live and work in the UK, and yeah, I've been doing this Blazor thing for a few years now, and it's going good. So I'm glad to be here to talk to you.
That's awesome. Thanks for joining us. We also have our wonderful co-host, John Galloway. Do you want to introduce yourself, John?
Sure. I'm John Galloway. I'm a PM on the .NET community team. And some of my favorite times of being at Microsoft are watching Steve Sanderson's demos. Steve, you blew my mind with the .NET Conf thing. And I been digging through the code and just loving all the stuff that you did there. So I'm very excited about today.
Yeah, it was an amazing presentation. So yeah, really looking forward to what you have to show us today. And let me just introduce myself briefly. My name is Tanay. I'm also working on the Blazor team. And yeah, I'll be co-hosting with you today. So let's start off with some community links. This is where we just show off a bunch of cool things that people in the Blazor community have been doing, projects that they've been working on, as well as new tools and resources that may be available for you to use. So let me just go ahead and share my screen off. Okay, cool. You should be able to see it now. So this is the community stand-up community links for today. They should be available down in the description as well. The first one I wanted to show off is just a YouTube playlist for .NET Conf. This happened back in November 2021, and this is where we actually unveiled .NET 6 to the public. This was a huge launch event, and we had a bunch of really amazing presenters who talked about all the new features that .NET 6 has to offer, as well as a lot of the cool new things you can do with .NET and .NET 6. So if you haven't seen these talks, amazing talks, definitely go check them out. The next thing here is a community project. It's called Nodexer, and it's essentially a regex parser and editor and visualizer that's built using C# and Blazor. So the GitHub repo is here, but rather than go through the repo and the code and all that, I really want to show you what it looks like. This is a really beautiful application, and it's extremely configurable. And for someone who may be, for example, learning regular expressions, or maybe even just wanting to play around and understand what their current regular expression is doing, this is a great example application for just that. So, for example, currently, I don't want to get too deep into regex because that can get pretty complicated pretty quickly. But essentially what's happening here is we have a negated set. So we're allowing anything but the quotation mark and 0 or more characters of that. And we want that item surrounded by quotation marks. So essentially what this translates to is we're looking for a coded string. So here we have some people when confronted with a problem, blah, and so on. You have a coded string. I know I'll use a regular expression. So if I want to do something else, like instead of having a negated set of anything but a quotation mark, I can invert this and look for, say, numbers specifically. So now if I do something like 1, 2, 3, that's going to get picked up by this regular expression. So having this sort of functionality, it becomes really configurable, and it's all done in a really beautiful application. So I really wanted to show that off today.
Just funny thing about that, the .NET, the live.net site, so it's live.net, parses stuff out of the community link or out of the description. So live.net, so it parses the description, and that's actually how we show the link for community links and also for the link over to the Twitter avatar, Twitter URLs. And so we actually, from time to time, have had things where people would enter it in slightly different format. So an application of regular expressions in real life, and I'm always going out and using tools to try and parse and understand them, because regular expression is something where always, as soon as I'm done writing it, come back and look at it, I got to relearn it again. So this looks really useful.
Yeah, definitely. And just being able to understand and easily play around with it, because again, regular expressions aren't the most straightforward thing all the time. So just being able to say, okay, I want an atomic capturing group or something like that, and seeing what that actually does visually on a sample text is really powerful, and I find to be really useful. So yeah, for sure. Very cool. Okay, cool. Let's quickly move on to the next one. This is FOSS design or FOSS components. And this is a kind of a component library where it shows you a bunch of great components that you have available, things like radios, radio buttons, toggle menus, checkboxes, and so on. It's easily configurable whether you want to change color themes, as well as things like border radius. Yeah, you should be able to see that live, as well as things like stroke width and density and so on. And this is a framework that works across many different frameworks. For example, it works in Angular, ASP.NET, Blazor, React, and so on. Today, of course, we're going to be talking about the Blazor integration of this. It's extremely easy to set up, and all you really have to do is create a new project, add the appropriate libraries, add the appropriate JavaScript script so that you can actually have the framework components and so on, and you can go along and work with components directly. It's really easy to set up, and it can allow you to create some really beautiful applications. Okay, and the last two are pretty similar in this content side of things. The first thing is a podcast with Dan Roth, who's the principal program manager for ASP.NET and Blazor. And here he's talking about a bunch of the features that are available in .NET 6, whether it be things like hot reload or rendering components from JavaScript. We also have a great presentation from Tim Corey, who also talks about a lot of these things with Blazor and .NET 6. So definitely, if this is some stuff that you're interested in and you'd like to know what actually is available in .NET 6 now, these are great resources to check out as well. So that basically wraps up the community links section. Let me just close it off. And from here, we're going to be handing it off to Steve Sanderson, who's going to be showing us a lot of the amazing functionality that's available with Blazor WebAssembly and .NET 6. Steve?
Yeah, all right, cool. Well, I'm looking forward to doing this. Let me just check. Are you showing my screen now? Because I don't have a second monitor here, so I can't tell.
Yes.
Okay, all right.
Yes.
All right, cool. All right. So what I'm hoping that we can do over the next half an hour or so is look at some of the enhancements that we've added to Blazor in .NET 6. And the way that I will be doing that is by showing some of the same content that was shown at .NET Conf. I'm sure some people may have seen it and others will not have. But what will be a little bit different this time is that you will be able to ask me questions live while we're going through it. So don't be shy. I'm happy to stop and take questions at any point as we go through. All right, so I've got on the screen here a massive list of some new features we added to Blazor in .NET 6. And you can see it's a lot of stuff. We obviously don't have time to go through it point by point and see every single thing there. So what we're going to do is take a specific scenario, like a business scenario, and imagine which of these new features would actually be relevant to solving our business problems. Okay. Now, the scenario that we're going to have is a fictional space agency. So imagine that I'm a billionaire, and like all billionaires, I want to have my own space agency. So I set one up, and I call it Blazor Orbital, which is a great name. And we'll imagine that you're going to come and work at this company, and you're going to be a software developer here. So you would want to know a little bit about how the company's software and architecture works. So I'll give you a quick overview. We've got some central servers which handle all our business critical data and our auth and things like that. And that's built with ASP.NET Core. We've also got various front-end UI applications, including one for the manufacturing group. These are the people who design and build rockets and manage all the warehouses and stuff. And they've got a front end implemented in Blazor WebAssembly, which communicates through gRPC to the servers. Then there's a different team called the missions team, and they've got a front end that they've implemented in React. So it's just a different group of developers. They made a different technology choice. That's how it works in the real world. And so they manage the missions that are in flight as we go. And then finally, there's another group of the business which maybe is a little bit more old school. And this is the accounting team, and they have a native Windows WPF application. Oh, and there's one other group who make shared libraries that we sometimes use, and they work exclusively in Rust, whether or not that's convenient to you. Okay, so we're going to imagine that you're working on this manufacturing hub, and as you're doing so, you've got some new requirements to satisfy for a new feature, because we've been having a bit of trouble in the warehouses, losing track of where things are and how many things we've got in stock. So the CEO would go to you and say, hey, we need you to build this new inventory management system. And it's got some interesting requirements. Okay, so firstly, it needs to support very fast and powerful queries. But in doing so, it's not allowed to place any heavy load on the servers because they're busy already. Also, this is a space agency. We need to tolerate failure. Network connections may go down during a mission, so it needs to keep working even if the user's offline. It needs to be not just part of the manufacturing hub, but also part of mission control and accounting, even though those are built in with other technologies. I don't know how you're going to make it work, but you just have to do so somehow. And then finally, we need you to be able to print these shipping labels with QR codes, and the Rust team has made a library that makes QR codes. So I don't know how you're going to consume a Rust library, but just do it, okay? So those are the requirements for our application. And let's have a go at doing them and seeing which of the Blazor.NET 6 features would help us to satisfy that. So I've got a starting point here where we've got this solution with a few different projects in it. So we've got the accounting app that I mentioned, the central server, and this manufacturing hub. We've got a grid library that we'll use in a little bit as well. And before we look at code, let's just start it running. Okay, so here's the application. And the first thing it's going to do is it's going to tell us that we have to log in, because you know that central server requires authentication. And if you don't have an auth token, it won't let you talk to them. So I'm going to log in like that. And then when I'm logged in, hopefully we will be able to communicate with the central server. We can access all this data about, you know, what's going on in the warehouses and things like that. But we don't really care about that. What we care about is this inventory screen, because this is where we're going to build the warehouse management system. But to do that, we're going to need to have some way of writing a database inside the browser, okay? Because if we want to support working offline, we can't talk to the server every time we need to query for some data. So wouldn't it be nice if we could use a real industry standard database such as SQLite inside the browser? And wouldn't it be nice if, since this is .NET, we could actually talk to it using EF Core, .NET's leading tool for working with relational databases? So we might try and write some code like that. And in fact, I have done. Let me show you. This code won't work, by the way, but I want you to see it so that you can understand what we're trying to do here. Okay, so this is the page that I just showed you. Okay, it's got a bit of Blazor Razor markup up at the top, and it's got this button that's going to call a method called runEFCore. All right, then we've got an EF Core database context that defines the structure of our database, and it's going to use SQLite for storage. And when we click that button, it's going to try to create the database. Then it's going to try and insert a row into it, and finally, it's going to try and query it. So let's see if it actually works, shall we? When I click the button, what happens is we get an unhandled error, which I was expecting. And if we have a look inside the browser console, we'll be able to see what the unhandled error was. And it's this: DLL not found eSQLite 3. All right, so why is that? Well, this actually makes sense because SQLite is not .NET. It's some native code written in C. And although we can compile it to a DLL. Can you just use a DLL inside the browser? Not really. No, it's only running WebAssembly, not some native code. So if you were on .NET 5, that would be the end of the line for you. There would be no way of going any further. But the first big feature in .NET 6 that I want to show you solves this. It's the ability to take native libraries written in something else that's not .NET, such as C or Rust or Swift or something else, compile it to WebAssembly and link it against your application. So in this case, I want to use SQLite. So I've got a console, a browser, a terminal command line here. And if I look in this directory, you'll see I've got the source code for SQLite. So they actually ship it as this one giant C file, which is really portable and convenient because you can compile it in lots of different ways. And in this case, I am going to compile it using the Emscripten C compiler, which is a C compiler that produces WebAssembly binaries. So that's going to compile SQLite 3 and produce a shared library, which is called eSQLite 3. Now, these warnings are bogus, so we can ignore those. But what we've got now is this new file, eSQLite3.0. And we can link that with our .NET application and use it. And to do so, we can use this new feature with .NET 6. I've gone into my project file here, and what I'm going to add is a native file reference. So I'm just going to paste that in. All right, so that is going to add a reference to the eSQLite 3.0 file that we've just compiled. And next time I compile my application, it will take a little bit longer than normal to compile because it's actually going to link some native code with the application. It's taking far, far longer than I normally would expect it to take, which is perhaps because of
all the screen sharing.
Screen, yeah. But anyway, we'll put up with it. Okay, so it's linking it now, and when that's finished, hopefully we can run that same code that we had before and get a slightly better output. All right, so just waiting for that to complete now. I would say it probably takes about 3 seconds normally if I wasn't sharing my screen, but I am. So
I mean, and just in case it's not clear to people what's going on, this I think is kind of mind-boggling. You're taking a C library and it's compiled to WebAssembly, and you're including it in Blazor WebAssembly that you're then sending down to execute in the browser.
That is 100% correct.
Yeah.
Absolutely. All right, then. So let's see what happens now when we click that button. Do we get an unhandled error again? The answer is we do not. There's no error. And in fact, every time I click this, you'll see it's adding more rows into that database and querying them back. So we've got a real SQL database, not some kind of like fake thing, but a genuine real SQLite database running inside our .NET application now. And that unlocks a lot of powerful possibilities for us. And we can solve a number of these difficult business requirements by doing that. So let's have a go, shall we? Let's imagine that you have done a few more days of work to create a system for synchronizing data from the back end into this SQLite database in the browser and displaying it in a grid. And we don't have time to go through that step by step. So I'm just going to drop in a bit of code that does that. Okay, so I'll show you more about how this code works in a minute, but I just want it to start running. Now, we'll talk more about hot reload in a minute, but what I've just done there is put in a lot of code, too much for the hot reload system to deal with. So it's telling me that it has to restart the application. So let's just wait for that to rebuild and restart. Here it comes. And now we're going to have quite a bit more stuff going on. Okay, so the first thing is that because we're starting from an empty database inside the browser here, it's going to go to the server and it's going to start synchronizing all the data that it can get into this local database. And it's going in super slow mode at the moment, but you understand why it wouldn't normally do so. And it's going to display it in this grid, which is, a live working grid in the background there. And I'll show you a little bit of the code that's running here. So this is the updated file. And at the top, firstly, we're setting a specific page title dynamically. That's actually another new .NET 6 feature. We've then got this component that I've added called sync status, which is responsible for this getting updated data thing here. And then below that, we're displaying a grid. And this grid is just a simple grid that I've created. It's in this solution. You can see the source code to all this later if you want to. And then to actually populate that, we are setting up an iQueryable, which we can add some queries against later. Haven't done yet. And then when the component starts, it's getting the entity framework DB context for this SQLite database. And it's saying whenever it changes, I want to update the state of the UI here. And similarly, we unsubscribe if you navigate away. So that's really all that's going on in here. And it's still being epically slow.
A few questions on that real quick, because it's a little bit mind-boggling. But few people are asking, this database is only running in the browser now at this point, right? It's not on the server. Where is that? Can you show the connection string? Like, what is there a file that it's being stored in then?
Yep, I will show you. Right, so we've got this client. Oh, is that the right one? Yeah, here we go. Here's the connection string. So it's file name equals, and then just some file. And where this is actually being stored is inside a virtual file system that's provided by Emscripten. So normally developers don't need to care about this stuff, but hey, you ask, so I'm going to give you the details.
Yep.
So there's no real file system that the browser can access, of course, but Emscripten simulates one. So if you use .NET's normal file APIs, you'll see files and you'll be able to create files, and they're really there, but they're only transiently available inside the browser's memory. If I reload the page, it would all be gone. However, in this case, if I hit reload, let's see if it has to start synchronizing again from scratch or whether it already has the data. I'm sure you can guess, but it already has the data. And that's because there's a little bit of JavaScript running in the background, which is synchronizing this virtual file system to the browser's underlying IndexedDB storage. So it's kind of ironic that we're storing SQLite database as a big blob inside IndexedDB. And I don't know if you know this, but IndexedDB itself is implemented in SQLite. So it's a slightly bizarre situation, but the performance of it is actually superb. So we've got a massive amount of data here. Well, we've got 100,000 items, and we can do things like sorting. We'll do some filtering as well in a minute. I can jump to any point in this massive, massive list and just instantly get to the specific row. And just to show you there really are 100,000, I'll sort it that way. Okay, so this is a virtualized list, and it's using EF Core and iQueryable to just fetch the relevant page of data as you're scrolling and display that small number of elements. Does that make sense?
Yes, it does. There's actually a couple of questions related to that. Yeah. So first of all, someone's asking, why did you use IndexedDB? Why did you not use IndexedDB and use SQLite instead? Yeah,
so IndexedDB is okay if you've only got extremely simple requirements. IndexedDB is not even like 5% of the power of SQLite in terms of the stuff you can do with it. It's like a very simple way of storing a bunch of two-dimensional tables, but it doesn't really have a proper concept of querying. Like you can't do joins, for example, when you're querying. You know, it doesn't have, honestly, it barely does anything. So if you're trying to do something that is non-trivial, then you would run off the end of the runway, like on day one, if you're using IndexedDB. But, you know, for certain application, maybe it's sufficient. But, okay, you know, sure, like everyone's pretty familiar with what you expect a relational database to do and what you think you can do with EF Core. And SQLite just gives you all of that.
Okay, fair enough. Makes sense. And kind of related to that, but essentially you're working with Blazor WebAssembly, you have a DLL and all that kind of stuff. So at the end of the day, could you run this in a static website as well for SQLite?
You absolutely could, 100%. Yeah, and in fact, we can run this. We can run this offline as a PWA, which I could show you later if I want to. So obviously, there's no web server involved at that point. It's just pure, offline static content, and it will work exactly the same way.
That's crazy. So static website, SQLite, you can serve it off a file server or whatever.
Yep, absolutely, you can. Yeah.
Okay. And just one more question, quick question before we move on. Just out of curiosity, what's the actual payload size of the SQLite payload?
Ooh, I don't have it in my mind right now, but I do have a slide comparing the size of this application in different build configurations that I'll show you a bit later. Will that cover that question? Yeah. Great.
I think so. Yeah, that's great.
All right then. So let's talk about a different .NET 6 feature now. Let's think about hot reload a little bit. So let's imagine we're trying to do a bit of work on this grid, because let's say we want it to look a bit better than it does currently. For example, at the moment, you see that price column. That's kind of bizarre. Like, what on earth is that number there? What is that? So let's try and make this a little bit more intelligible. So I'm going to go over here, and I'm going to start working on that a little bit. So you'll see within my grid, which I've just invented for the purposes of this demo, we've got this concept of template columns, and I'm going to start working on that a little bit. Okay, so I need enough space to be able to see what I'm doing. Normally, of course, we'd have multiple monitors, but we don't today. So let's say we want to format that as a currency. So I'm going to use .NET standard currency formatting feature. And when I press save on that, hopefully the hot reload system that's part of .NET 6 will wake up, and it's going to change the code inside my running application, except I've just changed more than one thing and I've caused it to reload. So you'll just have to bear with me while I do that.
And usually this is all blazing fast. It's just, I think, the screen sharing and the webcam and all that kind of stuff just, it ends up using a lot of resources.
Yeah, absolutely. I mean, it would take about half a second to 1 second to update after code changes normally, but it's going to be a bit faster now. I've done the first one. So let's say I look at this and I say, actually, that's all wrong, because these are the price in cents. So this is US dollars, not British pounds. So let's change this a little bit. We'll put a $sign in front of it like that, and I'll press save. And then this time, rather a lot quicker, I would hope, or except apparently not. It's going to update eventually. There we go. Right, it's done it. So after it's done it successfully at least once, I think it's going to be a bit faster. All right, so this is the price in cents, not in dollars. So I'm going to divide it by 100. Okay, I'll press save. And then this time, it's going to... All right, I'm going to give up on claiming that it's fast. It is fast normally, but not under this configuration. All right, so that's kind of really the price in dollars. That's good. Let's just change it a little bit more. Let's say I want it to... not have the cents afterwards, and I want it to have comma separators as we go. So that's hopefully going to look a little bit better now. All right, this is kind of absurd, but anyway, the key point is, as well as making these changes, we're not losing our state. Okay, so notice that I didn't lose my sort position. My scroll position. And if I sort in a particular way, then when I make further changes, it's not going to lose that either. So let's say I want to right align this stuff. Okay. Then when I hit save on that, it's going to change to be right aligned, but it's not going to lose the scroll position or the sort order, as you can see. All right, cool. So we could carry on adding more and more stuff to this grid. And under normal circumstances, we'd have a pretty great developer experience with that updating roughly in real time as we type. But we're not going to go through all of that step by step. I'm going to just jump forwards to a slightly later state in this development process where I've added some filtering in as well. Now, I've made a load of changes there by just pasting them in, and that's going to be too much for the hot reload system. So it's going to have to actually restart the application. So the way the hot reload system works is for certain types of edits, it's capable of patching them into your running application without restarting it, without losing any state. But for other types, it will detect that it can't do that because we haven't implemented support for it yet. And it will actually reload in the browser for you. Okay, so now we've got this slightly more sophisticated version of the application, and we can do things like, filtering for a particular category. And you can see I've got this multi-select thing going on. That's another new .NET 6 feature, is that we can bind to a multi-select list naturally now. Or I could start typing in here, and you can see, I don't know how all this comes across on the broadcast, but that's updating in approximately real time on each keystroke.
It's really smooth right now.
Yeah.
Cool.
So
And then I've also
100,000 records, and you're able to do that because it's full database SQLite running locally in the browser there.
Absolutely. And then finally, we've got this stock filter thing. And if I move this stock slider, nothing at all happens, which is deliberate, because I wanted to show you what code needs to be written to make this work, just so that everyone can understand how this querying works. Okay, so we've got these two stock sliders. Let's have a look at what that means, how that's represented in code. All right, so here's the stock column. And you see I've got options where I've got a range slider for min stock and another one for max stock. And these are bound onto two C# fields, which are here, min stock and max stock. And if we look at the querying logic, that's this bit where we're constructing an iQueryable. It doesn't say anything about min stock and max stock, which is why it's ignoring those. So we're going to need to put in a little bit of code for that. But the reason I wanted people to see this is just so you can see it really is a normal standard iQueryable, where we can use normal C# logic to build up a query, and then EF Core will translate that into efficient SQL, which in turn will be executed very fast by SQLite inside the browser. So if I bring in the necessary code to filter by min stock and max stock, then hopefully next time, as I move the sliders, we're going to see this actually take effect. Does that make sense? Mm-hmm. All right, cool.
Yes,
so
yeah.
Excellent. Let's just reload this. And then we'll see. And I think this is a sort of experience you wouldn't normally see in a web-based application, because normally it's kind of impossible to do this kind of real-time querying, because it would be too expensive to keep hitting the server all the time. But now, because this is a local database, as I move this, again, I don't know how well that comes across on the broadcast, but
yeah, it's instant.
Yeah, absolutely. If you see that number in the bottom left as it updates as I move this slider, like, when do you normally see a web application do that? You kind of don't, but it works really naturally with this sort of combination of technologies. So that's a bunch of business requirements satisfied. We've got some powerful querying, and we're able to do so without imposing any heavy server load. Okay, so I'm probably going to move a little bit faster, maybe just show you more of the highlights for some of these other things to make sure we've got time for everything we want to talk about. But let's just talk about this consuming a Rust library. Okay, so how would we normally consume? Yeah.
Sorry to interrupt you there. Before we move on to the Rust side of things, we just have a couple more quick questions for SQLite, if you don't mind.
Sure.
So
Absolutely.
There's a few questions with regards to the security aspect of this. So people are asking, can this be decrypted and stuff like that?
Yep.
So this is primarily a concern, I'm assuming, with actual connection string and whether you have credentials stuffed within the connection string. Sorry.
Yeah, it's a good question. The answer is that Blazor WebAssembly is a client-side technology, like JavaScript or Angular or React, or like something like a native mobile application. These are all client-side technologies. And one thing they all have in common is you can't trust them, because the user can make it do anything it wants to. Other than things like DRM type systems, digital rights management, users can always see and modify what their own computers are doing. So this database that we've synchronized for the user, it's their database, it's their data, their bytes on their hard drive. They can see them, they can do anything they want with them. You can encrypt it if you want, but it's pointless, because you've also got to give them the decryption key, otherwise the application can't work. So there's no way around it. You need to just accept the fact that the end user can see and modify any data that you give them. And the security has always got to be enforced on the server. So in this application, our central servers, which have this encrypted gRPC connection, they would also be responsible for enforcing any business rules you've got about who's allowed to modify what data and who can see what data, you must not try to enforce security on the client.
All the data you showed was on the screen, right? So
Yeah.
I mean, it's basically it's data you're giving to the client, and you're using this data not for the database is not there for security. It's for querying, filtering, performance kind of stuff.
Yeah, and the same is true with native mobile apps. If you build an iPhone app, you probably are going to store data in SQLite there as well, and a user can get that SQLite database and they can see it and even edit it. Like you really can't stop them doing that, and you need to not have a security model that assumes that this data is secret in some way.
Okay, fair enough. And kind of tangentially to that as well, how does the persistence aspect of this work? So, for example, say if you're adding a couple of new rows to the database, is this going to be persistent after your browser closes or something like that?
Yeah, so in this particular application, there isn't any editing feature. Like, I just didn't make it part of the demo. But if I had done, then yes, it would absolutely be persisted for this user. Of course, every user that uses this application has their own independent copy of the data. So you would be responsible for creating some kind of mechanism for synchronizing that changes back. In this application, I have got a system for synchronizing any changes that happen on the server to each client that connects, but there's no synchronization going in the opposite direction, and the developer would need to implement that in their own way.
Okay, makes sense. And I'm assuming it's being persisted because, as you mentioned earlier, it's getting stored onto the IndexedDB side of things. So
yeah,
the browser's handling the code. Okay,
yeah,
makes sense.
Right.
Thanks. Yeah, do you want to take it from there?
Cool. All right, so let's think about using this Rust library. Okay, so I'm going to click on one of these things, actually. So let's get this magnesium module, whatever that means. And you can see that this is the stock label that people in a warehouse need to print out sometimes. And we want a QR code to appear where this gray box is. But how are we going to do that, given that the logic for that is implemented in Rust? Well, I've started work on it already. So this is going to be very easy for us. I've got a Blazor component called qrcode.razor, which tries to render a QR code into an HTML canvas element. And the way it gets data for that is, firstly, code on the outside passes the value in to be encoded into the QR code. And when we receive that parameter, we're going to try and call this method generate QR code. And that's going to produce the actual data for the QR code. And the implementation of that comes from a DLL called librustqr. Or it would be a DLL if it was running as a native desktop application. But in this case, it's running as a WebAssembly application. And librustqr in this case actually is defined here as a native file reference. So in exactly the same way that we were able to link against the C code that gives you SQLite, we can compile against some Rust code that gives us librustqr. And that will be baked into our WebAssembly application there and becomes something that we can call. So if I go back to here and I uncomment that and hit save, then the hot reload system should see that I've done that, and it should rerun the onParameters set code. And you'll see that we now actually get a QR code. And I probably don't have time to go into the details of proving it, but this genuinely does come from some Rust code. In fact, I do have the Rust code that does it right here. You can see it exports this function called generate QR code, which is the one that we're running. But I know most people watching probably aren't Rust developers, so we won't talk about that line by line. But it genuinely is Rust, and it compiles to something that we can link against our Blazor application. Sound good?
Yeah, sounds great.
Awesome. Cool. So we can bring in...
I had one minor thing that like, as I was watching this and thinking about it, and I was playing with some stuff. Well, a few things that came across. One was people are like very much focusing on the SQLite thing, but I think the main point here is that you're using WebAssembly, like binaries from a Blazor application. So SQLite is an example, but it's not the feature you're showing off here.
Yeah, absolutely. This is not about SQLite specifically. It's about the fact that WebAssembly is this universal bytecode format that we can compile to from C, C++, Swift, Rust, other things. And then we can use them with our Blazor WebAssembly application, which is just something that was not an option prior to .NET 6.
One thing that I also thought of because of that, and I went looking around, I found there's WebAssembly Package Manager. It's wapm.io. and I'm sure there's some other sources of this, but this is an example where people have already compiled WebAssembly because SQLite needed some work to be done. You can't just compile like Postgres or any random app to run in WebAssembly, right? Something needs to be kind of built for that.
Well, for something like Postgres, I'm sure that's true. But for SQLite, it's not true because SQLite is spectacularly portable code. It's why it runs on just about every device in the world, including like your car and your toaster and your shoes or something. Like everything runs SQLite now.
Yeah.
So genuinely, the steps to compile SQLite to WebAssembly are what I showed you here. That's it. Literally that. I didn't make any other changes to the source code to be able to build it. But yeah, for some other libraries, it probably would involve passing special compiler flags to avoid using features that are impossible or something like that.
Okay. Cool.
All right. So we got a couple more business requirements. One is it needs to work offline. But as we've discussed already, it actually does already. So we don't have any work to do to make that happen. I don't think should I bother going through proving it? Okay. Which is the same application that we've just seen a minute ago. It's got the same functionality because it literally is the same application. And it's installed into my machine as a PWA, and it doesn't require the server to be there in order to start up and run. In fact, I will prove it. Okay, so I'm going to go and actually kill the web server completely. It's not there anymore. So it can't possibly tell me web server. It comes back up this time. It won't be able to get that data for the dashboard anymore. It's trying to do so, and it takes a little while, and then eventually it gives up and says, no, sorry, you don't have a good internet connection, or the server's down or something. And we can produce whatever kind of UX we want around that. And if I go over onto this inventory screen, then we'll see all the data is still there, still got all the same functionality as before. I can still do all the sorting and stuff, same querying as before. But you can see it says unable to get updates from server. So you can react to the fact that your server queries are failing and produce whatever kind of user experience you want around that. But the user can still continue to use the application, and all the functionality like searching or whatever, it's still there. It's still going to work using whatever data we had. Okay. So that was easy. The harder thing is making it work in these other applications. So we've built this Blazor application. What about using a new feature from .NET 6 to bring our code into a React application and a WPF application? We couldn't do that before. So let me show you this mission control thing. This is over here in this VS Code window, and this is written in React. It would be just the same if it was in Angular or Vue or something else. I just happened to pick React. Okay, and I'm going to start the application up in a browser. So this is something that our missions control team does to track the position of satellites and the number of days since we saw any aliens and other like business critical tasks like that. And oh, what have I done wrong? Oh yeah, I know what I did wrong. I killed my web server, didn't I? And I didn't bring it back up. So it's tried to talk to the web server there, and that obviously did not work out. So I'll bring that back up. And what we want to do is be able to bring our inventory management system into this React world. And ideally, I would have passed the no build flag when I ran that just then, but I didn't. So we will wait. All right, here we go. All right, coming back then now. All right, so in order to talk to the backend, we are going to have to be logged in. So I'm going to hit the login button, and this is using the same auth system that my Blazor application did. So it's like a single sign-in mechanism, and it will effectively log me in immediately with the same user because of my existing cookie. And then we could see all these different pages, but the one we care about is this equipment finder. This is where we want to bring our inventory grid in. Okay, so I'm going to reorganize the screen a little bit so that we can see hot reload taking place as we go through this. And let's actually get to the component that's relevant here, which is equipmentfinder.js. And let's reorganize that, and hopefully we're good. All right. So I know people watching may not be React programmers, so don't worry if you don't really understand what this is doing. There's not a lot going on here, actually. We're just displaying this markup to say use the inventory grid. And we've also got this search box where I can start typing stuff up there. And it's using React APIs to store that in a JavaScript field called search text. And I want to use my inventory grid in here. But how can I do that? Well, one way that you could do in the past, which is a bit rubbish, but you could do it, is you could just use an iframe. So an iframe is like a portal to another website, and we could just display our Blazor WebAssembly application in an iframe. But it would be rubbish because it would be like a completely separate world, and it wouldn't share any auth state. It wouldn't share any styling. It would be really hard to pass parameters in or get any data back out. What would be a lot nicer than an iframe is if we could just use a regular HTML element to display a Blazor component. And that is something that is made possible by a new .NET 6 feature. And if I show you the program CS file from a Blazor WebAssembly application, there's a lot of stuff that gets set up, but the bit I care about right now is this line here, which is saying that I want to take my inventory component and register it as a custom element under the name inventory grid. So this is a web component. Custom elements are part of the web component spec. And because I've done this, I can now use that in my React application or Angular or anything else. Okay, all I need is for that application to contain a script tag that loads the Blazor WebAssembly runtime, and then I'll be able to use this inventory grid inside there. So let's have a go at doing it. I'm going to put an inventory grid in there, and I'm going to press save. And hopefully React's hot reload system will take effect, and it's then going to add this inventory grid into my UI right here. And you can see it's the same code that we had before. And once again, it has to go through this process of fetching the data from the server because it's not an iframe. It's a completely separate website. So it's got its own separate storage location, but it is integrated with the same auth system. So because I've just logged in there, it's able to get the auth token from that, and that will be included when it tries to talk to the central server backend over gRPC, and then it's going to, display all the data that we want. So I think that's pretty cool, but one element about this that I'm not very happy with is the styling. You can see that it's got this kind of white background here, which is not great because the rest of Mission Control has a dark theme. So I would like to try and create a sort of dark theme here. And because this is a regular HTML element, I can use normal HTML and CSS to do that. In fact, I can use whatever mechanism my SPA framework uses. So in this case, I'm using React, and it's got all these different CSS files that control styling. So in this case, I'm going to say, I want you to find any inventory grid elements and any table that's inside there. And I'm going to apply a filter that says invert 1. Okay. So when I press save on that, hopefully it will apply my updated style to the page. Okay. Is it going to do that? Have I done that wrong in some way? I'm not sure what's going on because that should have just... Oh, there we go. It did it. It took a while, but it did it. And the cool thing you can see is we didn't lose any state here. Our .NET application is still running. You can see it's still in the middle of doing this synchronization process, even while we're changing the JavaScript and CSS code and hot reloading them into that system. All right, so that is pretty cool. But it's still not completely finished because if I start trying to type into this search box, you'll see it's not doing anything. It's ignoring me. And that's because we're not passing this data into .NET. Now, as it happens, my inventory grid takes a parameter called search name. That's just defined as a normal Blazor parameter. And I can use React syntax to pass a value from React into my inventory grid by doing that. So I hit save, and immediately hot reload happens, and you'll see that my MX query has now been applied. And as I type, then in real time, it's going to pass that data through on each keystroke from React into .NET and apply that. So that's
okay.
React.
Let me try and sum this up because this blew my mind the first time I was seeing it. What you've done, you've taken a Blazor component that you built with non-trivial stuff. It's got SQLite, it's got filtering, all that kind of stuff. You've packaged it as a web component with basically one line of code where you registered it as a web component. Then you're able to use it in React, or could be anything that can consume a web component. But you used React here, and you're passing a parameter from React into Blazor, and it all worked with hot reload, like across both React and Blazor, all in real time.
That's exactly it. Yeah, I mean, it's really nice how these technologies line up together. So I feel that this has got a lot of potential to allow people to use interesting combinations of technologies or migrate from one technology to another and so on. One last thing I want to share with this is
I think just to say, I think that's really great. You don't have to choose. Like if you're like, hey, we've got all this stuff built with React, but we've got this one neat thing with Blazor. It's great that it's all using web components to be able to share that stuff.
Yeah, absolutely. Yeah. Of course, you can do the reverse as well. You can use a React component inside Blazor as well, if you want to. And on the subject of doing things in reverse, I just changed some React code and it updated while retaining the state of .NET and React. But what happens if I change some .NET code? Would that be able to update as well? Let's go to the inventory.razor. And I'm just going to make a completely arbitrary change for the sake of it. I'm going to change this category column title from category to cat name, just so that we can see a change, and I'll press save. And you know it's all a little bit delayed at the moment because of the state of my machine. It would normally be instant, but if we wait a few seconds, then hopefully we are going to see this actually happen. There we go, it did it. So you can see that this has changed to cat name, and while it did, I didn't lose the state of my React code, I didn't lose the state of my .NET code. Both hot reload systems are working with each other as part of a single application. So it's a really nice developer experience. Okay.
Is this using the updated? So one of the things with .NET 6, it's not the subject here, but we changed the way that the React and Angular templates work and changed around the proxying bit. Is this using that?
It's actually not in this case. I didn't use the .NET templates. I was trying to be sort of authentic about how things are in a real business. So the React developers probably don't use a .NET template to create their React applications. They would use a React-based toolchain to do that.
Right.
So that's what I did in this case.
Cool.
But yeah, of course, it would work if you did it in the way that you just described. It's just not how things would normally happen in a real business.
Yeah.
Okay. So yeah, so we've made it go into the mission control React application. Last one then is, can we make it work inside WPF as well? This is actually not a .NET 6 feature. This is looking ahead a little bit to the time of Maui, which is coming this year. I don't know exactly when this year. But we've got one of the features of Maui is that we can add Blazor components to our native desktop applications. So I'm just going to start up this accounting application, which is a WPF app, but it could have been done with Maui if I actually knew how to build stuff with Maui. I just don't. So I've done WPF, and that's going to come up in a second, I trust. And I've actually done this already, so we don't need to write any code to make this happen. You're just going to see it working. But the important point to understand here is this is not going to run Blazor WebAssembly. Okay, it's going to run the Blazor components, but not under Blazor WebAssembly, not under Blazor Server, under a different kind of runtime altogether, which is just natively running the Blazor component in the .NET runtime that's already inside this application. So if I switch over onto inventory, then what we'll see is, firstly, it's going to require me to log in because, you know, in the real world, things always require authentication. So again, I wanted to be authentic about that. So we'll have to log in to get an auth token in order to be able to synchronize the data. But once we do, our same code that we had before is running, and it's literally the same code that says cat name at the top. If you're wondering why it's got a light theme and not a dark theme now, that's because the dark theme CSS was part of the React application rather than part of the underlying code. So that's not here, which is nice. But other than that, it's exactly the same application as we had before, and it's got all the same functionality. So if I, you know, start moving these stock sliders, then of course it's all going to work in the same way as before. So yeah, that's a Maui feature being applied to WPF in this case, and we've implemented all of our business goals there. So that's probably all I have to say about that stuff. Any questions at this point?
Yeah, that was all really, really amazing. I can't express how amazing that was.
Cool.
There's definitely a couple of questions here, so
Yeah.
let's just go through a few of them. This person asking, is this also possible with Blazor Server, or is this specifically for Blazor WebAssembly?
And the person asked that question while you were showing the React
Yeah.
the web component section.
Great. Okay. So I'm pleased about that because the answer is yes, that's absolutely possible. There's nothing WebAssembly specific about that. If your Blazor host application is Blazor server, it can also register components as custom elements and they will also show up. And in fact, you get some major advantages with that, like it's a much more lightweight system. So your React team is probably going to be much happier with you if you want to put some Blazor server components in there. And yeah, it works really well.
Okay, awesome. The next question was more regarding the native interop bits. This person is asking, is there any marshalling that's actually going on between the languages? So I guess between your Rust QR code framework and Blazor side of things.
Yeah, so that thankfully is something that .NET has been good at since V1, and we're just using that same thing here. So in this case, you see where we have the DLL import. There are various other parameters you can pass to DLL import to tell it things like how I want it to marshal strings or how I want it to marshal other structs and so on. And normally that is designed around interop with C, but WebAssembly is basically built on C-style conventions about how interop is defined. So all of those mechanisms that have existed since the beginning of .NET for controlling marshalling also work in this case as well.
Okay, makes sense. And the next question is related to the WPF bits that you just showed off. This person here is asking, can a Blazor page integrate into legacy MVC applications with deep linking and that kind of functionality?
Oh, hold on. Sorry, I think I missed something about that question. Can a Blazor application do what?
So say you have a Blazor page, say you have a Blazor component or something like that. Say the grid component that you just showed off. Can you have that show up within a legacy MVC application?
Oh, right. Yeah, sure. Absolutely. So that's not really WPF then. It's just, that's a different browser-based scenario. And the answer to that is, yeah, absolutely. So if you wanted to, you could register a custom element and render it from an MVC app or a web forms or a PHP or, you know, some CGI bin from the early 90s, like whatever, it's going to work because it's just HTML. That's certainly going to work. In the case of MVC specifically, there are more powerful options for you because you can have MVC render a razor view, which in turn can use the component tag helper to render Blazor components in even more powerful ways. So yeah, extra power for MVC people, but even for the people on other technologies, you could still make it work through a web component.
Okay, makes sense. And let me just pull off one more question. Okay, so this person here is asking, for the native file reference bits that you've shown, will that feature work specifically with WebAssembly, or will it work with Blazor MAUI too?
Yeah, oh, right. That's a great point, actually, because I completely omitted to mention an important part of this demo. Right, let me show you something. I'm going to click on this launch enhancer thing, and you'll see that the QR code comes up. Now, you might think, of course, the QR code is going to come up. Why wouldn't it? But let's think about what's going on here. This is not Blazor WebAssembly, okay? This is Blazor running directly on the .NET native runtime within the WPF application. And the QR code is Rust. And the QR code was compiled to WebAssembly, but this is not WebAssembly. So how is it working? What is going on here? The answer is that as well as compiling my QR code library to WebAssembly, I also compiled it to a native Windows DLL, which you can see right here. Okay. And the great thing about the fact that we use DLL import syntax is that if you're running in WebAssembly, it will get the stuff that's been linked using native file reference. Whereas if you're running on Blazor server or MAUI, then it will use normal .NET DLL import, which means it's looking for a native DLL within your bin directory. So as long as you can compile whatever you want to use to a native library for your platform, which such as Windows, Linux, or Mac, then you can use it through a DLL import on Blazor server or MAUI. And if you are targeting WebAssembly, then as long as there's a matching native file reference, then it will work as well. I realize how complicated that sounds now. I thought it was going to sound simple, but actually it sounds complicated, doesn't it? But does it make sense?
I think so. So essentially, whether you have the DLL or whether you have the native reference, it's still using the same underlying syntax with DLL import. Is that essentially it?
Yeah. That is absolutely it. Yeah. So because this was a Rust library, I set up like a multi-targeted Rust project that produces both WebAssembly and Windows output. I could have added Windows. What is it called? Mac, Linux. Yeah, I could have added other targets as well, and then it would have worked. But since it's a WPF application, I know it's only going to run on Windows, so that's why I only did Windows.
Okay, makes sense. And I think there were a few questions for this, but essentially people are asking where you got your grid component from. So within your Blazor Orbital example, what is that grid?
It's just a grid that I wrote for this demo, and it's not. Okay, I don't want to make it sound like everybody should be able to do this, because actually, in order to make this perform really well, I had to know quite a bit about how the Blazor renderer works internally. So if you look at this code, and you can because it's on GitHub, and I'll give you the link in a minute, you should absolutely feel free to use this in your project if you want to. Some of it might seem a bit advanced how it works internally for performance, but yeah, that's where it is.
Okay, awesome.
And that was a general thing that's come up, is people asking about, like, people actually wanting a grid kind of in the box. Is that, yeah. It's
on our backlog for .NET 7. I don't know. I've forgotten by now whether we committed to do it or not, but it's one of the items that's sort of under consideration for .NET 7 at least.
Cool.
Oh, actually, no, sorry. I need to clarify on that. One thing we're definitely not doing is creating like a sophisticated grid that like does everything that anyone wants, because there's already plenty of third-party component vendors that provide really good, powerful grids, and we're not trying to replace those. The thing that we're contemplating doing for .NET 7 is creating a kind of base technology that grids can be built upon to guarantee that everyone gets this like high-performance base without having to understand rendering internals, and then people can make, you know, their own grids on top of that. That's what we're actually thinking of doing.
Okay.
Okay, makes sense. Okay, we have a few more questions, but we can probably hold off on them for a bit. Was there something else that you wanted to show? This was all really amazing so far.
Cool, yeah. So I was wondering about showing something that's not actually Blazor related at all, which I know is like a shocking thing for me to say. But, you know, we are thinking about doing other interesting things with .NET as well. And it does sort of relate to Blazor a little bit, at least on the WebAssembly side. So if you're only interested in building SPA type applications, this bit might not be relevant to you. But if you're interested in .NET in general, then hopefully some of this stuff might seem kind of compelling. But to understand it, I need to show some slides, all right? Slides are a kind of necessary evil in this situation. Okay, so that's Blazor. Right. Let's think about the use of WebAssembly in other cases that other than in a browser. All we've talked about with WebAssembly so far is doing it in a browser, but there might be cases to do other things. And to understand why, we need to step back a bit and think about what WebAssembly actually is. So WebAssembly, at one level, it's a bytecode format. It defines a set of instructions that can be executed in a kind of virtual machine, and it's sandboxed to that virtual machine. It can't just access random stuff from the host machine. It can only do stuff that is allowed within that sandbox, which is rigorously enforced. So what stuff can it actually do? Well, by default, literally the only thing it can do is just perform operations on its own memory. It's got a big block of memory that's dedicated to it, and it can just modify the bits in that memory. That's literally all it can do by default, which sounds entirely pointless because you need to get input in and output out. And so to enable that, it does have one other capability, which is that WebAssembly code can import functions from the host, from outside, and it can, so that it can call methods on the host, and it can also export functions that the host can use to call into it. So that's literally all that WebAssembly is. And that raises some questions, such as, like, what are the actual functions that you would want to import into a WebAssembly module? And would it be nice if there was some sort of standard set of imports that were available to all WebAssembly? And that brings us to a concept called WASI, the WebAssembly System Interface, which I'm sure some people listening will have know about and some probably don't know about. So what this is a spec that's been around for a couple of years now, and it defines a standard set of system imports that allow WebAssembly code to do typical things that an operating system would let you do, such as access file system or read the current time of the clock and things like that. Okay, but it is still rigorously sandboxed. So just because the WASI spec says that a clock exists, that doesn't mean that a given WASI module has permission to read the clock. The host chooses to opt in to whether or not it can access file system, clock, sockets, everything else. It's chosen by the host. Okay, so it's still sandboxed, and it's not designed around browser or JavaScript-based scenarios at all. It's actually primarily interested in targeting server scenarios. So you might wonder, what is the point of doing that? Like, we can already run code on a server. Why would we want to run that code within WASI? Why are we just making things more difficult? And the answer is because it gives you certain really powerful advantages, some of which are quite similar to the benefits you get from containerization with Docker and similar things. So it means that if your application crashes, for example, it can't bring down anything else on that machine. The blast radius is contained, and only stuff within that particular WebAssembly module instance can be affected if something goes wrong. It also gives you some very strong protection against things like malicious data leaks. So everyone's concerned about supply channel attacks at the moment, and we had that whole debacle with Log4j over December. In that case, it was an outsider being able to trigger Log4j, being able to fetch some code from outside over the network and then execute arbitrary code. That couldn't happen if your code was running inside WASI, because if you didn't give it permission to access the network, then it wouldn't be able to fetch random stuff over the network. Or if you don't give it permission to access a particular area of the disk, then it won't be able to exfiltrate random files from you. So it gives you that rigorous enforcement of rules on a much more fine-grained basis than you're used to. And at the same time, it's still about maximizing performance. WebAssembly has always been about trying to give you near-native performance. And in fact, we can get even better performance out of WebAssembly on the server than we do in a browser, because we can do some much more aggressive optimizations. And then finally, it gives you much more portability than you're used to, more portable even than a Docker container, because it's entirely architecture independent. So your dev machine might have an ARM chip and your server might have an Intel chip, or vice versa, but it makes no difference because it's the same WebAssembly bytecode that can just work the same across every machine. Okay, so who is behind all this? Well, the original spec comes from Mozilla, who also brought us WebAssembly in the first place. But since then, it's been pushed forwards by a group called the Bytecode Alliance. And that is a collection of companies that you may have heard of, one or two of them. And yes, Microsoft is one of those. And the Bytecode Alliance is making sure that this spec moves forwards, as well as providing some actual implementations of a WASI runtime. And there's two WASI runtimes that come from the Bytecode Alliance at the moment. One of is called WASM Time, which is a high-performance WebAssembly runtime for the server. And then another one is called the WebAssembly Micro Runtime, and that's designed for more resource-constrained scenarios. But it's not just Bytecode Alliance. There's also other third-party companies that are producing WASI runtimes, such as WASM, which I happen to like quite a lot, as well as some others. And in general, there's quite a lot of hype about this. If you go looking for it, you'll see lots of people very excited about this. For example, this guy who created Docker suggests that if WASI had existed in 2008, they just wouldn't have had a Docker, because, perhaps WASI is actually a better way of getting the sort of containerization with even more portability and control. And so maybe this is the future of server-side containerization. So interesting,
question,
right? Yeah.
I'm kind of stuck on that. Like, how does this relate to Docker? What's the difference? I don't know if you're already going to talk more about that, but like, how do you think about that? Because in my mind, I'm like, I've already done the work to learn how Docker does its thing, and we've got Kubernetes and we've got an ecosystem.
Yeah.
How does this relate? Why are we doing this?
Well, this definitely doesn't replace Kubernetes. Okay, this might just be one of the things that you run inside your service cluster within Kubernetes. But it's an alternate way of doing containerization that is, like I said, platform independent, as well as being aggressively sandboxed. It's able to give you whatever access to the host machine that you want, but no other access, and able to be very fine-grained about things like So you're making a function call, and within this function call, how much memory is it allowed to use? How much CPU time is it allowed to use? That kind of thing. Like, it's just way, way more detailed than you would get by putting stuff in Docker. And it's also much more lightweight. And that's probably the biggest benefit that I should have led with. So in Docker, each of your Docker processors is effectively running an entire operating system. And I know the virtualization is fairly efficient, but with WASI, there's no operating system around it. It's just WebAssembly bytecode. So it's, your smallest WebAssembly runtime might just take like a few kilobytes of memory. Like, you're not going to get a Docker container running in a few kilobytes of memory.
Yeah.
So it's a much, much more lightweight approach.
Perfect. Okay.
All right. So this is interesting, but I've got some bad news for you as well, which is, if you're a .NET developer, the bad news is that our existing way of running on WebAssembly does not work in this way. It will not work in WASI. And that is because of how we compile the .NET runtime. In order to get the .NET runtime into a WebAssembly form, we compile it using a toolchain called mscripton, which is kind of old. It's been around since the beginning of WebAssembly. And the way that works is, every time you try to use any operating system functionality, it provides an implementation for that using JavaScript. Okay, so that's how all your existing .NET code is able to run inside WebAssembly and access, things like file system or network calls and things like that. They're all being provided by JavaScript, which is great if you're in a browser, but is pretty bad news if you're not in a browser, because JavaScript is not part of WASI. Like, that's not going to be part of WASI because it runs completely contrary to all the goals to be lightweight and sandboxed. So we need an alternative to all that. So a little experiment I've been working on lately is an approach to compile the .NET runtime to WebAssembly, not through mscripton, but using something called the WASI SDK, which is built on LLVM. And what that gives us is a way of satisfying your calls to OS primitives using WASI itself, using the primitives provided by WASI. So no JavaScript is required. It's much more lightweight, and it's able to run across all these different WASI runtimes. So I'm going to show you a little bit of doing that. And we're going to start with some super basic thing, which might not in itself be particularly exciting, but we've got to start with something basic. Okay, so I'm going to switch over to a different solution here. And what we're going to do is just run some code in a console application. So let's go in here. And as you can see, I've got a rather basic bit of .NET code here that doesn't do anything very interesting. But can we run it under a WASI runtime? And to do that, I'm going to go to my command prompt again here. And I'm going to run this script that I've already set up. And that is calling the WebAssembly micro runtime and telling it I want to run my console application. And as you can see, we get the output, hello from .NET. And just to prove that that really is the code that we write here. So let's say the time is datetime.now.to long time string. Okay. All right. And then I'm going to run that again. So that's going to see that I've changed my .NET code. It's going to rebuild the .NET code there. And then it's going to pass it back to this WebAssembly micro runtime again. And hopefully we will see the updated output from there where it's displaying the time. All right. Now, because this is truly WASI compliant code, which doesn't use any features that are outside the WASI spec, I can run it on other WASI runtimes as well. So for example, I've got the WASM runtime here, and I'm going to try to run my console application that way as well. This is actually not going to work, but I want you to understand why. So when I call this, you'll see it says error, failed to run, failed to load .NET-app.dll. Now, this is because by default in WASI, the intention is that everything is locked down by default. So the code can't even access the disk by default, and that's why it failed to load my DLL. And if I say, actually, you are allowed to access the current directory, then this time it will run and successfully complete. And it's, reasonably fast, despite my laptop being ultra slow right now. So that's running .NET inside a WASI environment for some simple console code. But could we take it a bit further? Could we build something that, say, has a web server? Because that's the sort of thing that you really want to do, is to build network services. So I've got this sort of fake little web. It's not fake, but it's very basic web server system. This is not ASP.NET Core for real, but it's just some little thing that I've put together where you can register get handlers and post handlers and stuff. Okay, and I'm going to see if we can run that as well. All right, and that is going to run under the WASM runtime because it's got experimental networking support there. And hopefully we will find that we can actually run a web server this way. So here it comes. All right, so it's now listening. I'm going to go to that in my browser, and it says, you know, the time is this, and that is coming back from this code here. We've got this other endpoint called info that's going to, that's not what I want. Let's go to info, and you see we can get some data back out of the HTTP request. In terms of performance, if we go and have a look on the network tab here, we should see that generally, if my laptop wasn't so slow at the moment, it would be like 3-4 milliseconds or something. It's slowed down to 6 milliseconds. But that is exactly the same amount of time as it would take for Kestrel or Nginx or something else to establish an HTTP connection and then respond to it. So there's not really any particular overhead from doing this. And we can run our code in a way that's really aggressively sandboxed, which leads on to some slightly more interesting scenarios, which I will move on to. But are there any questions or confusion about this so far?
So far, this is
not really. Yeah.
Yep, this is great. I guess just one question here. When you say that WASI allows you to interface with the underlying operating system or some of the functionality there, what kind of system resources or APIs are we talking about? Can we access the file system? Can we access the sound card or something like that? Or what is available?
Yeah, so the WASI v1 spec does have file system access. It's quite limited in terms of other stuff. So it does not give you access to playing sounds. It's really oriented around building things like command line tools or network services. It's not about like building games or UI applications or anything like that. So there's no ability to play sounds. The networking spec is actually still they're still working on that, so that's not officially standardized just yet. But there are lots of ways, and different runtimes have got different levels of support for networking at the moment, which is how I've built this HTTP server example. But as the person creating the host application, you can plug in your own additional functionality if you want to. So if you provide an implementation of any functionality you want, you can expose that as a WebAssembly import into the code that's running there if you want to.
Okay, that makes sense. Thanks.
All right. So I would say that although it's kind of cool that we can do this, it might seem pointless so far because we can already run .NET code on the server. So like, why would we bother wrapping it in WASI? Is it really benefiting us all that much? And I think that if we didn't write new kinds of applications, it would be a bit pointless. But the point of this is that we can potentially write new kinds of applications that work in different ways and have got some advanced powers and capabilities that wouldn't be possible without this sort of thing. And one of the ways that I find interesting to illustrate this is by thinking about different WebAssembly on the server runtime environments and the sort of capabilities they have. And there's lots of different things that people have created here. An example of one of them that I want to show you is this project called Lunatic, which is where someone has got inspired by Erlang. Erlang is this like distributed actor model system in which everything is ultra sandboxed and guaranteed that if any part of your application goes down, then it can come back up again. It's all about fault tolerance and manageability. And so they've created a WebAssembly runtime environment where instead of just running a single unit of WebAssembly code, you actually split your application up into a large amount of microprocessors, maybe tens or hundreds of thousands of independent microprocessors, each of which is completely sandboxed from each other. And it has its own memory space, its own set of capabilities, and so on. So if, for example, you were building a web server or a web application, you might say, for every single HTTP request that comes in, I want to spin up a new microprocess that will have its own isolated state. And that way, I can guarantee that I never accidentally leak state from one user to another user. I can also guarantee that I'll never actually leak memory because all the resources will definitely be cleaned up as soon as that request ends. It also gives us you the power to impose really strict management on your application. So you could say, for all requests to a particular endpoint, they're only allowed to use a specific amount of memory. They can only use 50 kilobytes of memory per request. Otherwise, I know something's gone wrong and I want to terminate it. You could also say something like, it's only allowed to use a specific amount of CPU time for a request on a certain endpoint. Now, you can't do that sort of thing with normal ASP.NET Core. You can't say, this endpoint is only allowed to use this much memory, because there's just one big heap. It's all kind of pooled together. You don't have any separation like that. But with something like Lunatic, you could. So I wanted to have a go at integrating .NET with that. And I've got an example of that right here, where I've got something that looks like a console application, but it actually builds on top of Lunatic. So each time there's a request, we're going to display the number of requests that we've handled and the current time. Okay, and the number of requests is stored in a static. So if this was a normal ASP.NET Core application, every time a request comes in, we'd increment that static and we'd see this number go up. Let's see what happens in this case, though. So I'm going to go run on that again. And let's see if we get a slightly more interesting output from this. So that's going to start up now. All right, so I'm going to go into my browser and we will see the number of requests that have come in and the current time. And I'm just going to clear all this stuff up while we wait for everything to fully spin up. All right, so we've had one request. This is the current time. And I'm going to reload that. And you'll see that the timer's updated, but the number of requests still appears to be 1, which might seem a bit strange. Did we not increment it? We did. But the reason is that for every single request, we're creating a separate microprocess here. So there's actually no sharing of memory or any other state between any two requests, which is why it's effectively always reset back to a starting point, a fixed starting point for every single request. And to demonstrate the thing about resource constraints, if I go to this URL, it's going to try to allocate 10 megabytes. And I've actually set a policy that they can only use like a few megabytes or something like that. So if I go over here to allocate, then what we'll see it does is it says out of memory. Which is cool. It's not actually out of memory. Like my laptop's not out of memory. The web server's not out of memory. But the policies that I've defined on these microprocessors says that for each one, you're not allowed to use that much memory, and therefore .NET reports it as out of memory. So
where
we can
did
guarantee.
You define that policy? Is that part of the Lunatic configuration?
Yeah, so I've defined that policy in the host layer that's starting up this application, which is not. This is not how this would work if it was made into like a real thing. This is just like prototype level stuff. So it's not really super interesting to show you where I've defined that, but it's in some C code actually. Yeah, so point being, we can now control things on a super fine-grained level, and we can guarantee that just because one request gets into an infinite loop or tries to allocate too much memory or starts running some malicious code unexpectedly, we can guarantee that it doesn't start influencing any other requests that are taking place on the same server, which I think has got potential to improve the way, the kind of reliability that we build our web applications with. Now, I want to be super clear that there is absolutely no specific plan to build something on Lunatic, for instance. I don't even know who makes this thing. I don't know if it's under active development. It's just an illustration of the fact that having this extra layer of management gives us the power to impose a lot more controls than we would have been able to in the past, and potentially build dramatically more performant code than we would have, dramatically more reliable code than we would have done in the past. And it also means that we can potentially write simpler code as well. Because in this world, it doesn't actually matter too much if we allocate a lot of memory, because it will all be flushed atomically at the end of the request. So, you know, as ASP.NET developers, we've believed for a long time that allocation is evil and you need to avoid it. But in this kind of environment, it actually makes no difference whatsoever. You can allocate as much as you like. It's no different from just using stack data. It will all just get flushed instantly at the end of the request. It also means things like async await becomes often something you don't need to worry about, because if your WebAssembly microprocess blocks, it doesn't actually cost you anything. So you don't necessarily have to worry about that either. So potentially you get more reliability combined with greatly improved simplicity. But I emphasize, just prototype, just thoughts, experiments, no specific commitment to build anything like this. That's it.
That's really interesting. Yeah.
That's awesome. Thank you so much for showing this. It's like always nice to see like what could be coming next, or kind of the areas that we may be exploring to get that sort of feedback and also show off. Okay, this is what's possible now. This is kind of like what could be possible in the future with all the amazing work that's going on.
Awesome.
I don't think there are too many other questions left. There are definitely a couple of people asking which Visual Studio theme you're using there, though.
Yeah.
They're really liking the contrast you have going.
I'm pretty sure that's the standard dark mode, isn't it? I don't remember ever changing the theme. If that's not the standard dark mode, I'm surprised.
Okay. I think the colors may be a new functionality then with the tabs. So you have a blue tab, yellow tab, or could be mistaken. Not entirely sure there. Okay.
For the experiment you just showed there, if people are interested in, like, is the sample code available, or if people want to follow along with, I don't know.
Good point. So answer is no. No, it's not. Sorry, it only runs on my laptop right now. That's how much of a prototype it is. So I'm sure eventually we'll make something public with that, although I don't know what it will be or when. But yeah, not right now. The code you can get right now is the code for the Blazor Orbital sample, including the React and Rust parts and so on. And that's the URL that I've got on the screen just there.
I will share that out. This is a lot, a lot of really interesting stuff. It's exciting to see how the combination of like exploring, using the cutting edge of like all the different technologies that are available, but keeping it as simple as possible as well, like making it approachable. And so like this repo, I cloned it. The one thing is I made a rookie mistake. I needed to make sure the authentication server was running before starting the main app. But it's pretty easy to build and run locally. So I encourage people to check that out.
Cool.
Okay, that all sounds great. Thank you so much, Steve, for joining us today. This was an amazing presentation, and yeah, it's great to see all this come to fruition. And once again, thank you, John. It's been great. Thank you, of course, to everyone tuning into the stream. It's been great having you here, and we hope you got to see a lot of cool things that are now available in Blazor in .NET 6. So thanks all, and have a great day. Bye, folks.
Thanks.
Goodbye.